So, we will be discussing on the course on computer networks and internet protocol. So, today we will be discussing on the topic of circuit switching and packet switching, right. So, what we see when we look at any network or any communication network, it is a switch network. That means, if I have two nodes connected directly, or two stations, if we consider as a station, that source station and destination directly connected, then they can communicate to each other directly. But however, if they are in the some other network, then what I require? I require to switch between different devices, right, network enabled devices. It is true for our telecom connection also. When you are calling somebody, it is some other exchange, then there should be some sort of a switching between these exchange. So, it will be the phone, my phone is directly connected to my home exchange, then there can be other trunk connection and go on, so and so forth. It go on switching to the so long to the end, right. Similarly, for data network also, when we look at when two stations, source and destinations are apart, then they are require multiple hop which are being switched, right. So, what we try to look at is that preliminary of what are the switching technique, irrespective of what sort of network is there. It can be a data network, it can be a telecom network and type of things. So, what sort of switching techniques are there, right. So, that is our goal, and we will try to look more deep into the things when we actually see when we discuss about the protocols, right. So, so what we are discussing about is a switch network. So, communication between distant stations or end devices is typically done over network of switching nodes. So, some intermediate nodes are switching nodes, which allows me to switch to the things, or in other words what we say, we find a path between the source and destination, right. So, from the source to destination we get a path, and that path need to be established, or and your packets or the data or need to be information need to be transmitted from the source station to the destination through this switch network. So, switching nodes do not concern with the content of the data. The switching nodes typically is not concerned about the data. The purpose is to provide a switching facility or a path between the source and the destination. So, they are not what data is being carried, right. Later on we will see that different data has different type of necessities, right. So, a collection of node and connections forms a communication network. So, this collection of nodes and intermediate connections forms a. So, the nodes and the edges or the connection between the nodes forms the communication network, that we know. So, in a switched communication network, the data entering the network from the source station are routed to the destination via being switched from one node to another, right. So, that is very natural, that if I have two nodes at far apart and intermediate set of connectivity connection and nodes. So, the data need to be switched or hop between one node to another. So, couple of things, one is that there can be multiple paths, right. There can be no path, right, I cannot able to switch, or there can be a path at times while the communication is on, there can be one of the node fails or edge fails, and there can be communication problem, right. So, so there can be several issues. So, for this type of switch network. Nevertheless, if we keep those challenges and issues little bit apart, like we will look at those things, that how still reliability, whether it can be attained, if at all, what are the mechanisms. But what we try to see is that how this information or data from the source station or destination can go from one hop to another. Now, typically this is a example of scenario from the switch network. You can refer this data communication by Williams, which I am also referring in this case. So, this is a switch network, if we say, right. So, there are end systems, right, end systems, there can be mainframe, server, personal computer, and variety of things. There can be mobile devices and so forth, right. So, if so for them this is a switching cloud, right, or so to say that some way if I am connected, I will be able to communicate with the things, right. So, I am not bothered about this or I am a user is not bothered about this switching things, but if you try to look into little deep into the things. So, there are different category of switching nodes. So, if a packets come, if I want to communicate from B to E. So, B is this is the host or the connected switch or the connected node. In case of a telephone, we connect to our nearest telephone exchange, and then it decides in order to go to D which path it should follow, right. It can follow this path, this, it can follow this path, sorry, or there can be other paths, right, this, here and D, right, B to D. So, there can be different path. So, this intermediate switches need to decide that which path there should be followed, or there can be a predefined path. If I want to go from B to D, I need to follow 1, 4, 5, 3 D, somebody defined it, right. Nevertheless, this route or path need to be decided or need to be established by this switched network. So, this is the switching network, typical switching network thing, and there are the external things which are going on. Now, there are different switching technologies. So, switching nodes may connect to other nodes or to some station. So, in this case what we mean to say, there are two category of nodes, what we say these are switching nodes and these are some other nodes, right, these are stations. So, this is the terminology which are being followed here, but you in some places you will find that all are considered as source node, destination node, it does not matter. A network is usually partially connected, like it is not that all are all routes are established. So, that it is the routes will be established on demand and type of things, and however, there can be some redundant connection are desirable for reliability also, right. So, I can connect that network, like I can have only this path, only this path could have been there for B to C, but there can be redundant paths, so that the reliability, if 5 goes down, in this case I could have gone to 1, 2, 3 D. If 4 goes down, also this path can be possible, right. So, there can be reliable there can be multiple paths, right. So, two predominant switching technologies are there, one is circuit switching, one is packet switching, right. As the name suggests or roughly suggests, circuit switching is establishing a circuit or establishing a connectivity between the source and destination. This is the predominant thing, whereas the packet switching says it means that the individual from the source station data can be divided into different packets, which are being transmitted through this switched network to the destinations. We will try to see that both the things quickly. Now, circuit switching, it says that there is a dedicated communication path between two stations. Usually, there is a 3-phase thing. So, for circuit switching, I should have a dedicated path from the source station to the destination, right. So, how a dedicated path can be established? So, there are how this communication can be goes on, there are 3 phases. First one is a path establishment phase, the next is the transfer of the data or information from the source to destination, and the third one is the disconnection phase, or in other words, if you try to see, this establishment phase is basically acquire the resources, right. Suppose I want to talk to somebody, so I basically some other part of the world. So, what I am trying to do is allocating the resources from starting from my telephone connection to my nearest exchange, and there are different other intermediate switching nodes. So, I am allocating the resources, and interesting, and then I can go on communication. It can be bidirectional communication or full duplex communication, and once the communication is over, then I tear down the connection or disconnect the thing, right. In other sense, I release the resources, right. So, if there are possibility of 10 connections can be established, if when I am one is already in the communication path. So, one is blocked, one is already occupied, other 9 are available. So, there from there another type of things come up, that is blocking architecture and non-blocking architecture. So, if the connections, if all the 10 connections are blocked, then there may not be the 11th connection will get a that no connection available at this point of time type of things. That means, it is a blocking thing. So, on unblocking or non-blocking means I have enough resources to handle, that we will look at this. So, circuit switching must have switching capacity and channel capacity to establish connection, right. So, it should both have switching capability, that means capacity, that means that that number of paths are free, and not only that, the data which is being carried by the channel, that should have also the capacity to carry the information of the data. So, it should have both channel capacity and switching capability to establish connection, must have enough intelligence to work out routing. So, in some of the cases or many of the cases, it should have a typical intelligence to work out the routing. So, if A B wants to connect to D, what should be the path intermediate through the switching nodes, that need to be find out. So, it can be, there can be some algorithm, routing algorithm, some way of intelligence to work out the routing. In some cases, there can be dedicated path. If B to D, this is the path which is there, right. So, there can be dedicated path or algorithms to look at it. On the other hand, the packet switching tries to say that the station or source station breaks the message into packets, right, typically smaller chunks of packets. Now, packets are now becomes a independent authority, right. Packets are sent out from the network in sequentially one at a time, right. So, one packet after another it goes on. The stream of packets are routed through the network and are delivered to the intended destination, right. So, these packets are pumped into the network and these go on the network and they are delivered at the destination. So, there also can be two approaches. One is what we say datagram approach, where packets moves on independent things. One packet may follow say route 1, one packet may follow the route 2 and so on and so forth. Nevertheless, they reach the destination. And not only that, once this type of situation come, you cannot guarantee that they may reach sequentially, because the one say path 1 or the route 1 may be more congested than the path 2. So, the delay will be varying and so on and so forth, right. Whereas, there is another approach called virtual circuit approach, where a virtual circuit is established between the source and destination and the packets moves in that particular path. So, these are typically in the case of a packet switching network. Now, again if we come back to this our circuit switching discussion. So, there are predominantly basic 4 type of approaches. One is space division switch, another is time division switch, another is TDM bus, the time division multiplexing bus, and there can be combination of this type of things, right, of this switching things. So, these are the 4 predominant stuff. So, like a typical circuit switching network is like this, that from the which is this is, as we know that circuit switching is predominantly for that voice type of connectivity. So, the connectivity is like a telephone. If we consider a telephone, then it is this first office or this nearest exchange, then is switched to that. If there is a call from this A to destination B, so it goes on different switching circuits, so like things are established. So, a path is established from the source to destination. Now, this how these connectivities will be established by the at the intermediate things is decided by some protocols or some algorithms or some way intelligent techniques that how things will be established. Once established, this is dedicated for these things. So, that nobody can basically intrude into this path. In other sense, this path is reserved or the resources are reserved at different exchanges at different with different type of what we say resource allocation schemes, right. So, in this case it is connecting trunk, then intercity trunk, then another connecting trunk and going on the things, and there can be multiple other many other hops based on the things, but nevertheless the whole path is reserved. Now, if we just look at the space division multiplexing, so or in other sense there is what we say this sort of cross connect or cross points. So, one connects to 4 or 2 wants to connect to 4, then I switch on this type of thing. So, there is a controller or control station which basically tries to see that that which is connected. So, we have a this sort of a matrix type of thing. So, anybody can connect to the any other resources. So, it is a that was a single stage, it can be a multi-stage thing where you have this sort of switches in different multi-stage, and in doing so there can be optimization of this type of space division switching. Otherwise, if it is a whole matrix or everybody is connected to everybody by these things, like here if you see there are 10 to 10 this side 10 nodes, these are 10 nodes. So, in ideally we could have needed a 10 cross 10 or if this sort of situation was there. So, around means 10 cross 10 or 100 nodes, right, like 3 cross 4, here we are having 12 nodes, whereas here the number of points are much less. So, that we can have multi-stage switching, and then I can have a we can still establish connectivity into the things. But still then we have to look at whether it is becoming a blocking architecture or non-blocking architecture, how many can simultaneously talk each other and type of things. So, those consideration comes into play. So, there is a need of overall planning when we go for this type of switching strategies. So, in case of a time division sorry, there is a typo, in case of time division multiplexing. So, what we have there is so one is that no switching. So, I send it BCDA and it is received by BCDA, right, or there can be some sort of a switching, right. I want to send from D, the connectivity is that this has to go from to 4 has to communicating with 2, then I can basically here change this packet sequence. So, that there is a switching. So, BCDA a DCBA now become BADC based on that where the packets would go, right. So, this sort of things are possible here. This is a time division multiplexing, and instead of this we can have TDM bus or a mix of the different things. Nevertheless, for all these purposes what we have, there is a resource allocation, a connection establishment is required, then the communication, and then a connection tear down process is required. So, these are these things are required when we go for a this sort of circuit switching. The circuit switching on the other hand is extremely useful or extensively used for our standard telephone connections, right. All our exchanges etc., are circuit primarily circuit switch network means this our traditional telephone connectivities. Like we are talking about time slot interchange, so that I can have a particular switching things which basically with a control unit based on the things we can interchange or select. So, this can be sequentially controlled, and this can be a selectively controlled, that which data is coming in the thing. So, there is 1, 2, 3, 4, whereas I can selectively control from where the data has to come out. So, in other sense I simulated a switching techniques where things will be there. So, if we look at the switching circuit switching properties and issues, first of all, once connected it is some sort of a transparent, right. So, once connected it is the communication goes on in a transparent mode, like what we do in our telephone connections. Once it is connected, I am talking about our traditional telephone connections. So, once it is connected over this exchange and trunks and type of things, then it is transparent. It is as if it is a dedicated line between the source and destination with appropriate resources, so that you can go on communicating with the things, right. So, this is a dedicated connection. Secondly, what we have primarily developed for voice traffic. So, this was primarily developed for voice traffic or our traditional phone connections, right. In some scenarios or in several scenarios, it considered to be not efficient, right. Channel capacity dedicated for a duration of the connection, even a whole channel capacity which could have been properly multiplexed, right. I could have done a frequency division multiplexing, etc., or other type of multiplex. It is fully dedicated for the things, right. Or if even no data is there, the channel is wasted, right. Even if you are not communicating, holding the phone, or you are not, no data communication is not there, the channel capacity is wasted. No other party can use the things. So, it is a dedicated resource type of things. So, other things, other issues are that at times there are setup or connection takes time. So, establishment phase takes time to have a connectivity, because unless the connection is established, you cannot start communication. The basic assumption or basic condition is that there should be a connection between the source and destination. A full connection should be established between the source and destination. Unless it is established, then we cannot do. Otherwise, another thing is the data rate is fixed. Both the ends must operate at the same data rate, as it is a dedicated path and flowing, the data flow is in a particular data rate. So, your source and destination should the data rate should be fixed and must operate at the same data rate. Otherwise, there will be accumulation of the data or overflow of the data will come into play, which will adversely affect the connection. So, the data rate need to be fixed. So long as the voice things are concerned is fine, right, because first of all voice has its own means that communication has its own restriction with the devices at the end. Secondly, the human interaction can handle this data rate and type of things, right, if there is at all need is there. On the other hand, which is our primary interest for our data network is the packet switching. So, basically what it tells, it is typically small packets, the data from the station to station is typically source to destination and typically broken down into small packets. Typically it is 1000 octets or 1008 bits 8 bit packet or type of packet. The longer message split into series of packets. Each packet contains a portion of the data plus some control information. Now, here what is happening, as we understand that it is a packet and packets are moving independently. So, the packet contains the data and some control information which helps it in get routed to the destination, right. So, that is one information. So, what is the control information primarily for is basically for the routing or address informations, where I am going type of things or where to where I am it is moving, and there are other informations which are there in the things. When we particularly discuss about these packets, then we will be discussing those things, right, like. So, packets are received, stored briefly or what we say buffered and passed on to the next node. So, once a intermediate node receives a packet, once a packet reaches a intermediate switching node, it receives it, store it and forward it. So, typically it is that store and forward mechanism, receive it, store it and forward the packet to the next destination. So, like this, like I have a application data from the one end, there is a packet switch network and I want to communicate to the other end through this packet switching network. So, there are advantage, first of all line efficiency, single node to node link can be shared by many aspects of the many packets over the time, because now it is no dedicated path, I have small packets. So, the single node to node edge can be shared by different packets. So, packet queued and transmitted as fast as possible, right. So, at everywhere what we are doing, we are receiving, storing, forwarding. So, it is queued and passed to the next destination or next hop as far as possible. There is a possibility, or there is a what we say chance of data rate conversion, right. Each station connects to the local node at its own speed, right. So, nodes buffer the data if required equalize rates. So, as there is a store and forward type of mechanisms, the node has a option of synchronizing the speed, right. So, different communication between the different edges and different speed of different nodes may be different. So, it takes and basically make a rate conversion on the things, right. So, that is possible because these are small packets and are handled independently and each other. Packets are accepted only even when the network is busy. Even when in the intermediate network is busy, that packets can be accepted and delivery may be slow, right, which will be difficult in case of a circuit switch things. If the network is not there, it is basically a dedicated circuit, you can't do anything on the things, but here we can accept the packets and it will be delivered once the things are maybe at a slower rate, or once the availability is there. Definitely there are time limits over which it cannot wait and so on and so forth. Nevertheless, things will be there. And another thing is that I can have a priority on the things, right. I can say that this sort of packets may given be priority, or others can wait and type of things. So, prioritization of the packets or the communication, this is also possible. So, again here also what we see, there are two predominant techniques or two different ways of packet switch. One is datagram, another is the virtual circuit. Now, in case of a datagram, each packet is treated independently. Packets can take any practical route. So, if there are n number of routes or say there are 4 routes, 10 packets, this anything can packets may arrive out of order, it should not arrive, it not necessarily arrive in sequence. Packet may get lost or delayed. So, once some packet may get dropped or delayed, may not reach the things on time, or even may not reach at all. So, there can be other mechanism to look at it, but this is possibilities are there, up to the receiver to reorder the packet and recover from the missing packet. So, the receiver only sequence it, and if there is a missing packet, the receiver can take appropriate mechanism, like receiver can request for retransmission of the packet and so on and so forth. So, there can be appropriate mechanism, but that has to be done by the receiver end. So, like typically if we look at a packet switch network, so say 1, 2, 3 going towards this particular node can follow different paths and go on accumulating, go on this at the receiver end, it accumulates or it order the packets in that things in a proper way. So, other technique for packet switching is the virtual circuit. So, pre-planned route establishment before any packet is sent. So, there is some sort of a route establishment is there. Call request and call accept packet establish connection or handshaking. So, there are request and call accept packets and type of things. Each packet contains a virtual circuit identifier or VCI instead of the destination address, right. So, it is more decided instead of the destination address, it goes on locally, like if I want to transmit here, where next things I have to deliver, which in turn things will be there, right. But my routing is now somewhat table based, right. At every node I say that if I receive packet this VCI received from port number received at port number 1 will go to that with port number so and so forth. So, no routing decision required for each packet once the path is established, right. So, you do not have to individually, you do not have to take the routing decision. So, that it follows the things. So, it can be at times more efficient. Clear request to drop circuits. So, if there is a if the once the communication is over, circuit may have to be dropped. So, there can be a some sort of a circuit break means TR of request, and it may not be truly dedicated path. So, the circuit once there, if there is disruption or some other reason, there can be another circuits can be established. So, it is not necessarily truly dedicated path. Not only that, the paths can be shared by other virtual circuits also, right. So, I can have some sort of a multiplexing on the paths. Like here same thing what we are seeing, that a thing is established and then it goes on communicating in this particular sequence, right, in case of a virtual circuit. So, as we are discussing that it carries a PCI. So, if you see, if I have a switch here which receives a data 77, data 14 from at port number 1, then it decides that if it receives 14 from 1, it will push it to port number 3 with a VCI 22. So, this switching things are there, and if you see, this is interestingly localized. So, I do not have to have a huge number etcetera also, because it is only localized, like I can have other hops where some other VCI 14 can be there theoretically, right. So, this way it goes on switching. So, if it is a one port from port 1 VCI 77, it will go to port 2 with VCI 14. Now, this so if I have a larger scenario, then I can have some paths to communicate, right. So, it is for here it is 114 coming going to 366, this is port 3 packet VCI 66. If 66 is established at port 1, and then it will be pushed to port 2 at 22 with VCI 22, it receives at port 2 with VCI 22 and push it to port 3 to this. It goes from source to destination with different type of hops, and if you see, this table allows me to establish the route between A and B, right. So, this is a virtual circuit is established, data flows in this particular direction. So, if we try to look at the packet switching virtual circuits by the datagram, virtual circuits network can provide sequencing and error control, as they are having established path. Packets are forwarded more quickly, no routing decision is required for individually at the packet level. Less reliable, loss of route loses all the circuits to that particular node, and because a particular node can have more than one circuit which is established, and if that particular node is faulty or not working, then all the circuits to the node is lost. It goes for not only reliability, it also have extra cost of re-establishing the circuit and transmitting the things. Whereas Datagram, one hand this has no call setup. So, each packet moves independently, better if the number of packets is less. If a huge volume of packets are there, then there are a lot of calls is there. More flexible, routing can be used to avoid congested part of the network, right. So, we can have different routing things, so that if there is a congestion, then the other packets are routed to some other things etcetera. So, that is not affected, or better routing strategies can be there. So, if we try to now look at circuit switch and packet switched networks or packet switching networks, right. So, in case of circuit switch, bandwidth is guaranteed, right. So, that you have a established connectivity and your data flow through that. So, the bandwidth is connected, whereas in case of a packet switch, bandwidth dynamically allocated as needed, as need basis, right, or as and when needed type of thing. So, that is being allocated as there is a need, right. So, it is not guaranteed bandwidth. It may so happen that the bandwidth availability is not there, or when you need, because you are not preoccupying the resources. So, while communication you may face problem of dropping of packets etcetera, or loss of packets. Circuit capacity not reduced by other network traffic. So, it is not, as it is a dedicated circuit, the circuit capacity once allocated or once established are dedicated for this source and destination, whereas may have concurrent transmission over physical channels, right. In case of a packet switches may have concurrent transmission over physical channel. So, one physical channel there can be number of things. Circuit costs independent of the amount of data transmitted, right, resulting in wastage of bandwidth. So, whether if I establish a connectivity, whether I transmit or not, it is a dedicated connection. So, I pay for it, right. So, in other sense there can be effectively there is a waste of bandwidth, whereas there is more effective and better performance, because there is no such sort of a blocking the channel even you are not communicating, but they may have some delay and congestion because of its typical characteristics. And as we see that this type of circuit switch network is more amicable for voice communication, right. So, it is more amicable for voice communication, whereas this this circuit switch network, and whereas the packet switch network are more amicable for data communication or how data is communicated between the things. So, for our computing this particular course for computer network and internet protocols, we will be primarily looking at this sort of a packet switch network, right, where these nodes or the packets are independently moving from the source to destination, and in number of cases this is a unreliable best effort service. It depends on how things are there. If you want to have a reliability on the things, you should have a different mechanism of things that we will gradually study on in this particular course when we go on more deep into the things and specifically look at different protocols, their characteristics and type of things. So, what the primary objective of this particular lecture is to that to brush up that already most of you may be knowing that packet switch and circuit switch network. There are several other things we mention here. So, we had an overview of the things, but we primarily now look at that packet switched based things what we go on subsequent things, right. So, with this let us stop today, and we will continue our discussion in a subsequent lecture. Thank you.